all you can do.
Come on, little internet.
The internet's really struggling right now.
We might be live. I literally have no idea right now.
Okay, I'm going to open a soda and I apologize.
So you're gonna apologize for opening soda?
The noise
Oh, okay. For releasing carbon dioxide emissions
and the ASMR.
and the ASMR. Oh, oh, I don't even want to imagine. Hope no one's encouraged you to do some kind of ASMR stream.
No, although I've been accused occasionally that my painting ones inadvertently become that,
Yeah,
but it's not on purpose. And
yeah. Just
I
like
don't know if
I'm
others
just
can
gonna paint
see.
some little fluffy planetary features. Yeah, you're like Bob Ross of planets, of planetary formation. Look at his dog feet right beside you.
She's totally zonked out.
Yeah, that's so funny. All right, so don't forget to say hello before we begin. And in case you missed it, I had an absolutely fascinating conversation on my YouTube channel yesterday morning with Dr. Pekka Junhanen, who
Mm,
is a Finnish researcher and the developer of the electric sail, which is a
I don't
method
know
of
about those.
propulsion that is like a solar sail, but instead it uses you essentially run an electrical current through wires, and they react from the ions, from the electrons coming from the sun and the protons, and
Okay.
causes a propulsion system that could have you get out to the outer solar system in almost the fastest, cheapest way possible. So it was a great conversation. I highly recommend if people haven't seen it. Super fun. And it was great because the audience had all kinds of really clever ideas, and he was like writing them down. He's like, "Oh yeah, that's a great idea." As we were talking about, you know, this synthesis of all these other ideas. I'm gonna say hi to a bunch of people. Hello to 3D Studio Mike, Adam Synergy, Andrew Planet, Andy Cowley, Astro YYZ, Bill Sugden, Coalfire, Colin Jones, Coy Wagoner, David Moskrop, DPI 209, Dustin King, Guido Bibra, Hal McKinney, Henrik Bo Anderson, Holly Meyer, Ian Farquharan, John Seffield, Quad Libet, Kylie Cerna, Larry Beckham, Magnus Timer Jensen, Maria Kobetz, Mark Sheeran, Matthew Lear. Everybody's here today. Miss Brick Kitten, Nancy Graziano, Nicholas B., Paranor, Paul Disney, Paul Gracie, Paul Sursky, Raj Luthra, Rich Wilson, Arjone, Tesla Ranger, Therion, Tamas Traniker, and Yamagashi Sun. Hey, everybody. Welcome. When Worlds Collide. Yes, yes, it is a
Yes.
1951 American Technicolor science fiction disaster film that we did choose the name. You had an original name? I forget what it was, like something planetary collisions,
Yeah.
or litho atmospheric
I did not
planetary
do that. I would not have
interdisturbance.
done that. I did
Yeah.
have something that was much more boring,
Yeah,
which
yeah.
is why I don't name the episodes.
Yeah, I get to name the episodes. That is the one job that we have decided I am superior at. You
There
write
there was
poetry, and I'm just like, I just like to hit people on the head with what the title is. Okay, so if you're wondering what it is that you have stumbled into, oh man, my nose is so itchy.
spring,
I
all the
know, I spring.
pollen,
I'm
all the
I'm
pollen.
hopped up. I'm totally hopped up on allergy meds right now, and so like just the don't touch your face is just 7 times worse during allergies. But I'm not leaving the house,
So you can rub your
so I
eyeballs.
can rub my eyeballs as much as I want. As unless we have formulated some new kind of coronavirus right here in the house, and then we'll spread it out to the rest of the world.
So I'm having this moment of first world problems during coronavirus. I don't
Yeah.
know how else to describe it. So I'm immunocompromised. I
Yep.
should not leave the house.
Yep.
Other people will not let me leave the house. I am not allowed to leave the
Yeah.
house. Fine.
Yeah. Forbidden.
So I love Cadbury mini eggs. Adore Cadbury mini eggs. Normally during the Easter season, we stockpile. And every time someone goes to Walgreens, which is like a block away, so it's fairly often, it's like mandatory. You have to buy a
Right.
bag of mini eggs.
Yeah.
There are no mini eggs available on the internet anymore. You have to go in person.
Oh no.
And I can't. And the evil part of me is like, well, send the sacrificial grad student. And
To
and I know
death.
that's wrong.
No,
And
it's
I
not worth
can't.
it.
I know, but
Yeah.
it hurts my soul that I can no longer get any chocolate Cadbury mini
Yeah.
eggs.
Yeah. Try something else.
If this is as bad as it gets, I really have no way of complaining about quarantine. I am simply having a
Yeah.
moment of expletive, 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 but Cadbury mini eggs.
Yeah.
Could it have not chosen a different time of year?
Oh, well, I don't know what to tell you.
It's a first world
It really
personal
is.
problem.
Yeah. Yeah.
Yeah,
Yeah. No, I mean, that does not fit within the acceptable reasons to leave your house.
it does not. It
No.
does not. Part of me keeps being like, does someone need a prescription refilled? Because they have Cadbury eggs at Walgreens. I can see on the internet.
Yeah.
So I'm really hoping that someone has a prescription that needs refilled.
All right.
I'm a terrible human being.
Let us begin. If you're wondering what it is that you have stumbled into, we're about to record an episode of Astronomy Cast, episode 565, When Worlds Collide,
Can you adjust the screen capture so that, like,
so that you're not way down low.
yeah, I
Sure. Oh, not that. Hold on. Is that it? There you go. There, and there. And let me just see what you look. No, that one's all you. I can do
and no one
this.
can see the dog, which is
Oh, there. Now people can see the dog,
okay.
but they can't see the dog when we're split screen.
Okay.
All right. You ready?
Yep.
Okay. I am also ready. Let me know when you.
I am pressing record.
I have also pressed record.
It is recording,
The recording is happening. All right, here we go.
but it's not using the right mic, I don't think.
It sounded like. Oh, I heard that mic. Okay, I'm gonna stop
Yeah,
my
hold
recording.
on.
Do you
I
remember when
don't
Macs
know.
used to be easier? Remember those
So
days?
the fundamental problem is I have so many different pieces of equipment attached to my computer that, like, under the mic lists, it's like, do you want the built-in microphone? Do you want this synthetic mic? Do you want
Yeah,
that synthetic mic? Do you want your camera's
yeah.
microphone? Do you want Lord, I accidentally turned something on and it lost its mind. All right, I'm pressing record again.
Okay, I've also pressed record.
And
Here.
now it's correct.
Yay! All right, here we go. Astronomy Cast, episode 565, When Worlds Collide. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Just the usual, just getting by day after day. The overwhelming sense of anxiety and existential grief is fading, and now I'm busy. Just busy. I'm like really busy. I got a lot of stuff. I got a lot of stuff going on now, and
I,
getting through
are
it.
you finding that the extroverts in your life are creating video conferences?
No, that's
They, I'm having video conferences with people who I have never video conferenced before,
right.
and it's just okay.
Are they
This is
spiral? Are
what
they
we do now.
spiraling?
Yes.
Yeah, I
Yes.
I think, again, as the extrovert of this pair, I definitely am getting that process out of me because I do Astronomy Cast, I do the weekly Space Hangout, I do all of the other interviews and shows that I do. Plus, I'm hanging out with my son and I'm hanging out with my wife, and I went for a walk
Yeah.
with a friend of mine the other day. So I'm sort of feeling all that in, but I happen to live in a fairly wide open space. So I can, we can get out a little more safely than I think a lot of people out there. So I can just imagine friends, hunker down in New York City making
Oh,
these
that's
calls.
miserable.
Yeah, yeah. So
Yeah,
so if they
like
are
we
in
have a yard. You have a yard.
yeah, I have a yard and then I have an unlimited amount of forest after behind that yard, right?
Right.
That I won't run into another single human being. So, just like tough it up. This is the service that you're doing for your friends who are cooped up and are just dying for human contact.
But extroverts out there, remember how you feel right now so that when all of this is over and us introverts are like, this is hard work extroverting.
Yeah.
Remember how hard a work it is for you to introvert. Just remember this. But I will say, I am so grateful to live in the middle of nowhere because I do have that yard, that ability, and my heart reaches out to all of you who are in your studio apartments, who are living in situations that are less than ideal. We're here for you, and look for the Weekly Space Hangout. Look for the CosmoQuest Discord. We have a place for you to come and at least escape into a room on the internet only with people you like.
Exactly. All right, so much of our solar system has been shaped by enormous collisions early on in our history. Seriously, the nature of every planet in the solar system has some evidence of massive impacts during some point in its history. When worlds collide, Pamela, tell us about. Well, I'd be interested to know why we see these impacts all over the place before we start to talk about some specific events.
Well, we're at this really cool point in science where our understanding of how solar systems form is in the process of radically changing. Back when I was a graduate student, um, I remember learning that planets form in the solar nebula and sometimes they migrate to and fro. But in general, what you form is what you have. But then of course there was the Earth that got hit by something the size of Mars and that created our moon.
Yeah,
But other than
but
that,
apart from that, right?
and
Everything was standard. It all just formed in place. The
exactly,
Earth was
exactly.
different.
Yeah.
Yeah,
But then we started to evolve this idea to include um well there was this great heavy bombardment and the Nice model came up to explain how our solar system at one point had a resonance between Saturn and Jupiter that was responsible for flinging everything
yeah.
hither and yon. Uranus and Neptune went out to the outer solar system.
Switch places.
And the inner solar system, we just got beat up. We got beat up by the giant planets. And so that was the first major of evolution of how did we get to where we are. And then suddenly in the past year and a half, there have been a series of press releases that are basically saying, okay, now that our computers are getting better and we're thinking about this a little bit differently, Jupiter's core is really too fluffy. And that was the actual word, I kid you not, they used. Jupiter's core was too fluffy. How do we explain this?
Okay, well, see, I mean, how do we even know how fluffy Jupiter's core is supposed to be? And then how do we measure how fluffy it is today?
Well, so computer models can tell us how fluffy it should be. And because we had Cassini at Saturn, these things should scale politely. So, what we see at Saturn, we should see at Jupiter just scaled differently. And we didn't. Saturn and our models happily matched one another in terms of having this nice dense core that could have then attracted all of the gas particles around that dense core, building up this gassy world. It all was consistent and made sense. And you can measure the density profile of an object by measuring its, um, I just lost a word. I just totally lost a word. Moment of inertia. I found the word. Sorry, Susie. Sorry, Susie. You're gonna have to cut that part out where the word left me.
Or
Um,
don't.
or don't. Okay. So we can figure out the density profile of an object by looking at its moment of inertia as it rotates. A moment of inertia is a fancy pants way of saying how much of its core is located in its center versus in its outskirts. And we can see how the moment of inertia affects rotation with the standard example is ice skaters. They put their arms out, they slow down, they bring their arms in, and you're no longer sure how they're standing.
Right.
Well, you can do the exact same experiment rolling cans down an incline. Take a can that just has the weight around the outskirts of the can. Take a can that is equal density throughout the entire can. Take a can that you have suspended a core of material in the center of the can. Send them all three rolling down that incline, and they'll actually go down the incline at completely different rates because of the moment of inertia. They have to roll, they can't slide because sliding is just
Right.
gravity, and that's a different result. But as long as they're rolling, you can see their difference in behavior based on the profile of the content inside them by how they roll.
Hmm.
Well, with planets, we look at how spacecraft go around them and how they go around themselves, and by looking at the detailed nuances of rotation, these flybys that we get allow us to get at the moments of inertia of these worlds. And when you happen to have a spacecraft that hangs out for a long period of time, you can measure in detail the moment of inertia of a world.
Right. So, I mean, we've always talked about this that figuring out the mass and density of some object is very difficult unless something is orbiting it.
Exactly.
And once you have something orbiting it, for example, a spacecraft that you've sent to it,
Yes.
then that has all kinds of, that has all kinds of really good sensitive instruments on board, unlike Ganymede, boring Ganymede, which is really slacking off. You've got a way to really measure the exact behavior of the planet itself that your spacecraft is orbiting. Absolutely stunning. So then, based on these measurements and the fluffiness of the core, what do they think happened to Jupiter?
Well, there's this really cool model that was put together where what they looked at was if you have a still forming but fairly well formed Jupiter, and then slam into it violently with a many Earth massed object, what does that do? And effectively, what it does is it inserts a whole bunch of energy, and that heat fluffs up that core that had just condensed down, but the heat makes it more energetic and allows it to poof back up. And so by slamming something into it, adding energy to the system, it's it's a way of just increasing the volume the core takes up, lowering its density, and well, fluffy.
And
It always
is this
go
a
ahead.
temporary thing, or would it has it it's lasted this way for billions of years? So
Yeah.
so it what kind of an object must it have taken? Like another
A
object,
planet.
like something Saturn size, something Earth size, something Neptune, like big though, right? I
It
mean, Jupiter
it
is
would have
big.
been it would have been between Earth and Saturn in size.
Wow.
It's And this is the thing that we're now starting to realize is there were a bunch of these multi-Earth mass things
Yeah.
in the outer solar system careening around that weren't given the chance to stay planets.
Right. Like how long, from if the solar system formed, say, 4.5 billion years ago,
Mhm.
how long until most of these objects were scooped up and merged together into other things?
Well, it looks like our universe was pretty settled down by 3.5 billion years ago. So there would have been the early days of duck and cover, but without Saturn and Jupiter purposefully thinking things around with their resonant orbits. and Jupiter probably got fluffed up before
Hmm.
the Great Heavy Bombardment. So this was while things were still forming. It just happened to careen into something
Right.
else, and thus it got fluffed up in its early days. And as it settled down, it kept that overly large core.
So we know about the Earth and that the
Mm.
forming. We've talked about this on many episodes, so we'll just take this that everybody knows that the Earth was smashed by a Mars-sized object early on in its history and created the Moon. So we know about the Earth. We know about this new evidence of Jupiter. What else do we see as evidence in the solar system for these kinds of gigantic collisions?
Well, another case is Uranus. And we've always known that something weird probably happened to Uranus because where most objects in our solar system orbit such that if you took your right hand and curved it around the world, your thumb points up through its north pole and your fingers are pointing in the same direction the world is rotating. And this is consistent. North is up, following the sun, everything is going around and around the same direction, is pretty consistent. And the variations in tilt we see are generally minor. Jupiter, which is the largest object, the hardest to tilt, has the smallest tilt. Our own Earth is 24-ish degrees. Mars, I believe, is 29-ish degrees. Um, but Uranus is 98 degrees tilted over from
Right.
what you would expect compared to the sun. Its north pole got flipped below the
Right.
disk of the planets
Yeah.
ever
I
so
mean,
slightly.
those of you recalling your trigonometry recall that there is 90 degrees in an angle, and so for it to be, you know, you would expect that you would measure the angle that it's tilted over somewhere between 0 and 90 degrees. And yet astronomers measure it at 98 degrees, meaning it is completely that, we measure it from that north pole, and that north pole is flipped right over. So what happened to Uranus?
Well, we've been saying for ages that it was probably either hit or torqued over. And the idea of torque is what's happening that gets our moon in a tidal lock with the planet Earth. It's where you have something that is tugging on the world uh, in such a way that there's essentially a lever arm flipping the world sideways. With the moon, its center of mass is not its geometric center. It is actually higher density on the side closest to the Earth. So every time it tries to rotate away from us, our Earth grabs onto that overdensity of mass and pulls it back.
Right.
And this was what allowed us to essentially torque it into place the way it is right now. Now, trying to figure out what the lever arm is with an ice giant like Uranus is deeply confusing. So, when people didn't think collisions were common, there was a whole lot of maybe it got hit, don't really
Right.
know.
Well, I mean, you have that whole situation where, as you mentioned, the Nice model, where as
Yeah.
the planets shifted around, Uranus and Neptune went way out, and in fact, they switched places.
Yeah,
And
we think.
so you can imagine switching two planets, switching places at some point would bring them close enough to cause some kind of interaction. So that's still on the table.
But recently, folks have been trying to figure out where moons come from. And this is not as trivial as we thought. Early on, the idea of where did moons come from, it came down to, well, they get stolen. Mars stole Phoebus, and Deimos. Of
Yeah.
course it did.
Yeah.
And they form in situ. Look at Jupiter and the Callisto, Ganymede, Io, Europa. These worlds formed in essentially a mini solar nebula. And we use ALMA, we can actually start to see the eddies in solar systems forming around alien stars, where it looks like this idea plays up. And so we basically had two ideas. They are stolen
Hmm.
or they form in place. But then, of course, there's Earth's moon, and that's an exception. And how is it our world is always the exception?
Right. Yeah. Yeah. Right. I mean, literally, like the first rule of astronomy is you're not special.
Exactly,
Right.
exactly. But we didn't want cool stuff to be happening. We wanted the universe to be staid and regimented. And the universe doesn't care what we wanted. It's going to do whatever it's going to do. And so a team of scientists working through trying to model the formation of moons couldn't make sense of Uranus because here's a world that has tenuous, wispy rings of material. It has far flung moons. The masses make no sense. If you look at it as it all formed in situ or was stolen. Now, if you add the third option, which is you take a many Earth mass icy planet.
Hmm.
So take Pluto or Triton, and make them multiple times the mass of the Earth, which is consistent with the object that we think is out in the Kuiper belt
Right.
that Michael Brown is
Right.
searching for.
Yeah. So planet 10, planet
Right.
9. Right. Planet 9.
However, you choose to
Yeah.
number it, imagine it had a self destructive sibling
Right.
that 3 to 4 billion years ago, maybe 4.5 billion years ago, rammed itself into the young Uranus, broke apart, shattered, spewed vaporized material in all directions. Well, the thing is, when our Earth got hit by Thea, that Mars sized object and everything splattered, rock cools much faster because it cools at a much higher temperature. So we ended up with two objects quickly. Well, the difference in energy that you get for um, Uranus, and I said this backwards. I'm so sorry. Susie, I'm just going to do this to you twice today. So, the rock that we have here at Earth, it solidifies at a much higher temperature. And this changes the rate at which things are able to solidify. Out in the outer solar system, you have everything getting vaporized, but then it solidifies at an even colder temperature, and that changes the rate. And that extra time that was gained by the fact that you're in a colder part of the solar system and this stuff cools to solid at a colder temperature, it all played out so that Uranus was able to suck in all of the vapor, except for a little bit that was left in the outskirts where
Yeah.
rings formed
Right.
and a few big chunks that became moons.
And and possibly, and I know as well that in fact it might have taken several of these torquing events to actually complete this process of throwing Uranus totally over on its side. That it might have been not just one, but actually a bunch of these events, one after the other, as Uranus scooped up all the material that was roughly in its orbit.
And this is where what matters is a combination of where did the blow hit and what was the difference in velocities. So this is one of those really frustrating things where there's multiple ways to get at how Uranus is tilted on its side.
Yeah.
But the easiest way to account for the rings, the moons, and the tilt is one massive object coming in,
Smash.
hitting it with a glancing blow, tilting it over, shattering,
Yeah.
creating the rings, the moons, all of that at once.
Now you mentioned Uranus. We talk about something having 98 degrees, but that is not the most tilted angle in the entire solar system. There's another place that's even weirder,
Yeah.
or equally weirder. Anyway, let's not make them fight. They're both weird.
Venus was designed for the left-handed people in our solar system, and as a left-handed individual, I am
Right.
pro Venus.
So as long
So
as
if
you
you're
measure Venus's orbit using your left hand and not the right hand like you do for pretty much every other body in the entire solar system, then Venus is doing fine.
exactly either
Yeah.
that or it's just doing thumbs down.
Thumbs
So so
down.
so again, the way we do this is it's supposed to be with your right hand. You wrap your fingers in the direction of rotation of the world, and when you do this with the Earth, you end up with a moderate tilt. Gives us the seasons. We're happy. With Venus, you have to tilt your arm upside down
Thumbs
and you end up
down.
thumbs down. Thumbs down.
Yeah.
Venus is giving us a thumbs down. And not only that, but its rotation rate is totally off. We expect certain rotation rates based on conservation of angular momentum of the whole darn solar system. And there are exceptions. Mercury is in a resonance with the sun due to tidal forces. But everything else kind of more or less makes sense except for Venus, where its days are longer than its year.
Yeah. I've heard this said that you could walk on Venus and you could outwalk the sun. So if
This
you
is true.
so if Venus wasn't horrible enough for you already, you could always just have the sun beating down on you and you just walk at a regular walking pace just around and around the planet and you would be faster. You could outrun the night. Or you could do the opposite and never see the sun if you wanted to.
Both
So
sound
weird.
terrible.
So what happened to Venus then? What could have caused this situation?
And and a few years ago, I would have said, well, there's models that think it could have been brought about by a combination of torques from the planet Earth and its orbit around the sun, that maybe it was collided with. And because we don't have enough data, I still can't tell you, except that if Venus follows the pack, it got hit as well. And the question is when and by what? And Venus is one of these worlds that the more we look at it and the better our computers get, the more variables we're allowed to include in our models. We're starting to realize that quite possibly just within the last millions of years, Venus's climate might have been just a slightly warmer version of Earth, like everyone thought it was until Mariner
Yeah.
2 got there and crushed all of our
Although
dreams.
people really should have been looking at that, taking that thumbs down as a hint.
Yeah, it's true.
Yeah. How
It's
to,
true.
is there life on Venus? Mm, thumbs
Thumbs
down.
down.
Yeah. Uh,
But we don't know. Something dramatic and multiple epochs in time has happened to Venus.
so again, possibly, I know astronomers have absolutely worked out models where something big smashed into Venus, rolled it over. But I
And
mean, if all that happened to us was we got knocked over 23.5 degrees and we got a moon, just imagine what it must have done, what must have happened to Venus.
and the models that I'm desperately hoping someone will do and publish, because if you get boring results or you get null results, you don't always publish, and this makes me sad. The model I would like to see tested and published if it's a null result, please, is a model that looks at, assume as it appears to have been the case, that Venus was still a perfectly average, not death world until a few million years ago. Then slam something into it that would trigger the atmospheric changes that we have seen, and see if it's possible to do this in a way that also flips the world. I don't think you can flip the world without destroying the world.
Right.
So I'm pretty sure that this model will go, no, you
Yeah.
can't do this. I'm pretty sure this had to have been an ancient event that flipped it upside down.
Yeah.
but I still just want to know. I
Yeah,
want
yeah,
to
and
know.
we've done several episodes on, or several articles on Universe Today, as people release models showing here's how it might have happened, and this might have
Yeah.
explained why it also doesn't have a moon, like it gobbled up its moon and that flipped it over. So there are a bunch of interesting ideas, and then I mean we see evidence of really catastrophic events happening on Mars. We see really strange features on Mercury, which are evidence of some ancient collision.
Massive
We've got to go
collisions.
back to Neptune and Uranus to try and trace them out as well. But there's one last world that NASA is actually planning to visit, which is asteroid Psyche, which is
Yes.
is the leftover core of a planetoid, which is pretty cool.
And this is one of those things where you have to wonder how many other might have been worlds have we
Yeah.
just not found the cores yet?
Right.
And
Like, is
you
that
just
what our metal meteorites are? Is they are the cores of dead planets?
yeah.
Yes.
And just one of the things that has been getting me is the Atacama Large Millimeter Array, ALMA, is out there looking at solar systems forming around alien stars. And the images that we're getting back are 100 or hundreds of astronomical units in size. Our solar system tapers out at about 55 AU and becomes just plain boring, and we haven't seen the Oort cloud yet. But these solar systems that we're seeing around other stars are so much bigger,
Yeah.
which implies that things migrate inwards. And then, if the Nice model is correct, gets flung back out to a different point. Solar systems are yo yoing.
Yeah.
And what all could have formed spread out across 100 astronomical units? That's just amazing
Yeah.
to imagine.
And that's one of the things that's quite exciting is we do see planets colliding in other star systems. We see just all of this just incredible diversity across, the Milky Way so far with all of the instruments. Newly forming planets are actually a lot easier to find. Newly
Yes,
forming star systems in infrared observatories than fully mature planets. So actually one of the greatest amounts of innovation in this field right now is happening in these newly forming planetary systems. So if there's any answers that we're going to get more quickly than others, it's probably going to be what happens, what kind of mayhem goes on in these planetary systems early on in their history. Absolutely fascinating.
exactly.
Thanks, Pamela. Do you have any names for us this week?
I do. As always, we are so very grateful to all of you that really allow us to keep doing the show week after week. Now starting to be decade after
Decade
decade.
after decade, millennia
And you
after
allow us to place
millennia.
pay what was that?
I said millennia after millennia.
I'm not sure I'm as into the robot bodies as you are.
All right.
But we couldn't do this without Susie because what you see us doing here on the show, this is the fun part where we're just like talking about what we love. Susie has to edit. You let us pay Susie to do the thankless job of making sure that this goes from us talking to you actually having a show. So thank you. And these are the people we'd like to thank this month. Brian Nelson, Kristen Brooks, Eric Freringer, Martin Dawson, Kassier Pienflienko, Dwayne Isaac, Frode Tenaba, Shannon Humber, Justin Proctor, Thomas Tubman, David Gates, Rachel Fry, Iran Segrev, Frederick Shorga, Claudia Mastriomini, please, you can put in pronunciations. I apologize. I'm so sorry. Neuter dude, I know how to say your name. Paul Hayden, Omar Del Riviero, Brent Krenop, Tim Garish, and Arthur Latz Hall. Thank you. Thank you. I thank you more than I can pronounce your names, and I apologize. Thank you.
Thank you, everybody, and we will see you all next week. And then they saved.
Yes.
5 65.
Okay. See what all is out there. It was 90 degrees on Wednesday, which was deeply confusing. So in the 40s, those of you who speak Celsius. Today,
No, that would be
it's
the
like
30s. 30. 90 degrees is like,
30s.
yeah, low 30s. Yeah.
Okay.
Yeah, like 30 degrees ish, which is
Okay.
still ridiculous.
Yeah. Yeah. And it did that for one day. And today, it's like less than 10 degrees Celsius. It's like 40 something.
Yeah, we hit 18 yesterday. It was just gorgeous. And again,
Yeah.
just this just completely leads to this cognitive dissonance that you have where you're like, but it's
The
nice,
world is
but
ending.
the world is ending, but it's beautiful outside, but
Yeah.
apocalypse, but
Yeah.
yeah. Oh,
And one of the things that we're really struggling with is like you really want to support the local businesses, but you don't want to put people's lives in danger. And so I've been looking for what are all of the family owned places where I can say, hey, can you like put gardening supplies in my driveway and I will pay you through the internet
right.
and no one shall possibly encounter each other. And so we have a tiny family owned gardening store. And so I have a compost bin waiting to be assembled.
Oh, that's great. That's great.
Yeah.
Again, we've talked about this in the past, just how quickly, like, you think about all of the businesses that got shut down, and there
Yeah.
are some that will never be able to open up during
Right.
this pandemic. But you can see, say, restaurants starting to adapt to takeout and delivery more quickly. Like we are seeing some attempt to
Yeah.
piece our economy back together, because it really feels like, you know, I know a lot of people are like, oh yeah, I can handle this for another couple of weeks. If you think this is just going to be for another couple of weeks, then you don't understand what is happening. We are looking at some versions of social distancing and lockdowns for the better part of 18 months until the
Yeah.
vaccine rolls. Someone was just mentioning in the chat that a Chinese vaccine has been tested on 500 people, which is amazing. There was a American vaccine test already started about a month ago, I think, or 3 weeks ago. So but the trick with the vaccine is you gotta go for a year and a half to make sure
Yeah.
that it doesn't do anything bad. Like
Yeah.
like it may very well kill like stop you from getting coronavirus, but it could cause some other
Cancer.
health cancer. Yeah. And so what would happen if you figured that your vaccine was safe and then you gave the vaccine to everybody and then everybody got cancer, right?
and
Or
and then there's always the like sci-fi trope of the vaccine provided by the aliens that cures all these diseases and then also sterilizes all of humanity.
right. Yeah, yeah.
These
And so we have plenty of examples of things that were thought to be medicines back in history that turned out to be bad for you. And
right.
so we have this process of going through, of taking our time and being careful. And it may very well be, and even if they do have vaccines, the vaccines are going to be rolled out on a priority basis. So you're going to start with the people who are most, at risk, the healthcare workers, the
Yeah.
the grocery workers, the people who are with immunocompromised and old people, and then slowly move its way through. So we really are looking at this complete reinvention of the way many things get done across our entire planet. It's if there's one silver lining for me as the Canadian capitalist, I'm just excited to see all of these changes happen. I mean, it's wonderful to see that pollution levels are down around the world. That
Yes.
that apparently heart attacks are down because people aren't being stressed out about having to go into work. Um, you know,
The Japanese salarymen, all these companies that had been torturing these young individuals,
yeah, yeah.
they're all working from home
Working from home,
now.
they're doing all right. Yeah,
And what I'm really loving, especially where I live, because a lot of rules are slower to break down in the middle of the country. Things get tried on the coast and then migrate inwards.
yeah.
And so we're seeing all these prohibitions against like liquor delivery and stuff, or just like forget it, just
Yeah,
do it. We
yeah,
don't care
yeah,
any
yeah,
longer.
exactly. Yeah, here it comes. Yeah,
And and so my favorite brew pub, the one where we did the Astro 500 event, Recess, they now have beer delivery, and they have a tent set up outside their store so that you basically socially distance, give your order, it gets put on the table, they step back, you walk forward, you pick up your
yeah.
growler, and now you have beer.
That's really awesome. Yeah, I think our local brewery has some. I haven't checked. I haven't even bothered getting alcohol during this time, but
I follow
maybe.
them on Facebook, so I've seen all the ads, and
Yeah,
our grad student has had to go out and run errands and gone past, and he reported on the tent.
yeah, yeah. We'll have to find out. I wouldn't mind getting a a fill of beer maybe tonight. It's a Friday. I'll go
Yeah.
take my jug down to the brewery and see if they'll fill it.
So I really encourage all of you. Like, Amazon workers are crying out for help. Do not order things from Amazon if you can avoid it.
Yeah,
Get on the phone to your
yeah,
local companies and see if you can work out a look, I'll pay extra if you can deliver, and keep everyone safe and keep these small businesses employed.
yeah.
Um,
I was
we can do
continuing to
this.
pay our cleaner. So we
Yeah.
have a cleaner who comes by, and I just kept paying her the regular amount. And don't worry, there's going to be a lot of work when she returns. Um,
Oh, yeah.
but actually, she told me to stop because in Canada now we've got a grant that comes from the government for companies that are affected by the shutdown. And if your
Okay. So
business
she's
is
fine.
affected, so she's covered by it, and so she's like, you don't have to give me money anymore. We're all right,
Okay.
which is great. And hopefully, but I can't even imagine a way that she can do her job and still protect, for everyone to be protected. So her
Yeah.
business is done if for the foreseeable future, right?
Yeah. Some businesses are.
Yeah.
Others, like cupcake businesses. I've been watching Cupcake Wars because it's a
Yeah,
safe show.
that's easy. Deliver
Um,
cupcakes.
yeah,
Yeah,
exactly.
no problem.
Um, and all the places that have curbside, you open your trunk, they put things in.
Yeah.
There's ways.
Yeah, yeah, yeah. I have some friends of mine run a Dairy Queen here in town, and so they've closed down the restaurant side, but the drive-through is booming,
Yeah.
and they'll probably have to figure out a way to increase the capacity of the drive-through to be able to handle more cars coming through.
Yeah.
So we'll figure it out. In the end, we will figure this out. Um, let's see. Let's take some questions.
Okay, I'm going to look through the Twitch side while you look
So
through.
Corey S asks, do we know the total mass fraction that is taken by all the asteroids yet? Where do these massive objects go to? So one stat that said a bunch of times is that if you took all the asteroids in the main belt and mashed them all together, you get an object with 5% the mass of the moon.
Yeah.
So there's
It
not a
got
lot of
consumed
mass.
into other planets.
Right. Jupiter mainly gobbled them up or threw them
I no
around.
longer feel comfortable saying mainly, except for the fact that it's the biggest thing.
Yes.
But yeah. Okay, so we're here. There's no real questions over on Twitch. So YouTube, you've got it.
Okay. So Quadlibit asks, why flip the whole Venus? Wouldn't it work to just fine to boop a slow spinning planet and nudge it to spin the other way? That's a
Um,
great concept. I love that.
I love that. So it turns out it takes a whole lot more energy to reverse something's spin than to flip it over. And you can experiment with this if you're feeling daring with a bicycle tire and a small axle.
Yeah.
Um, this is a standard science demo where you put a handle on a bicycle tire and you have someone else start it spinning, and it's really hard to rotate. So get a feel for how hard it is to rotate the entire wheel that's rotating. Now, instead, figure out how much energy it takes to take that spinning wheel, slow it down, and get it spinning in the
Right.
opposite direction.
Right. There's a great experiment you can see they do in on the space station. So
Yeah.
astronauts discovered they were spinning cylindrical objects on the space station. Like they take like a long bolt, and you spin it so that it's spinning with along sort of the like it looks like it's just rotating along its longer axis. And after every couple of seconds, the entire thing flips over, and now it's flipping completely upside down, and then it flips back, and then it goes back and forth doing this every couple of seconds, and it's a really interesting thing. And there's some great videos that explain why this happens. You could scale that up with a with an O'Neill cylinder, and you
Yeah.
would get the same thing. You have this gigantic O'Neill cylinder, and any slight perturbations in it would flip the whole thing upside down over just a couple of hours, and then it would be spinning upside down and backwards, and then it would flip all the way over because
Yeah.
there are these other cycles that are going on in microgravity. Absolutely fascinating.
Broken Symmetry has a really cool question over on Twitch. Sorry, there
Yeah,
was one
yeah. There
question
you
on
go.
Twitch. Um, could one object strike Uranus and continue away to be pulled back again later for a second impact or absorption? So this is like a galaxy collision, but now we're looking at a semi-solid body where you have that glancing blow, but the fragments are now caught into an elliptical orbit and get pulled back. I don't see a reason why this couldn't
Yeah,
happen where it only went through like the outer atmosphere on the first go.
it got torn
Um,
apart. Went through the Roche limit, got torn apart, and then the
yeah.
fragments came back in one after the other at various inopportune times.
I don't know if that matches the energies of what we see at
Right.
Uranus, but could that happen in the universe? Yes.
Yeah. Yeah. Um,
Super cool question.
yeah, I like that question. Play with Universe Sandbox, and
Yeah.
you'll see what will happen. I mean, the whole situation does get resolved pretty quickly though, so it's not like it would take a billion years. Like
No, yeah.
it would happen within years, and it was
Yeah.
all in one final ball.
Yeah.
3D Studio Mike asks, since Venus rotates so slowly, wouldn't it be more susceptible to tidal effects with the sun becoming tidally locked soon?
Um, I don't know if it's so the distance that something is away from the sun, the effect goes as the square, which means that if you triple the distance, it's 9 times
Right.
less effective.
So you really have to be close for for to get tidally locked to the sun.
Yeah. The sun alone isn't enough to tidally get Venus locked in. You have to have something else that is stealing energy away that helps
Right.
accelerate the locking process.
Unc Willie asks, is it possible that when Venus turns itself inside out, that it flips too?
So this goes back to the classic model for Venus, where the idea is because it doesn't have plate tectonics, all of the heat inside the world, instead of escaping at the edges of the plates through volcanism like we see here on Earth, um, it periodically, basically, the entire world erupts at once when the energy gets too high.
Yeah.
Now, what's kind of amazing is just in the last year, people are like, well, maybe not. Kind of looks like Venus has ongoing hotspot
Right.
volcanoes like Hawaii.
Hmm.
And so it could be that all of our past ideas for what Venus is like were misassumptions based on what we saw from Magellan, the radar returns that we got, and didn't properly take into account the chemistry of the atmosphere that has these tantalizing hints that maybe there are active volcanoes today.
Right. Arjone asks, does Jupiter put a size limit on any of the other planets, or could there have been a much bigger terrestrial planet than the ones we have?
So you can have a much bigger terrestrial planet than what we have, up to the point that it becomes a gas giant or an ice giant. So the mechanics of the solar system limits how big different worlds can get before they become a different kind of thing.
Right.
There's some fuzzy areas between terrestrial world and ice giant where it depends on where in the solar system you form, because there's just not enough spare gas in the inner solar system because the sun is effectively either sucking things in or pushing it out. So you get heavier, denser objects initially.
Right.
Everything can move later. All bets are off later. But this is our current understanding.
Cujo and Friends asks, hey Fraser, could black holes be considered antimatter since they are not physical matter and destroy any matter that enters its event horizon? Now, we've done whole episodes on this, but let's answer it again.
No, no,
No,
no, no, no, no, no, no. So black holes are just stuff
they're black
that is
holes.
sufficiently dense that light can't escape it. The properties of them are just a scaled up version of the properties of everything else. And just like the room that I'm in right now, it has a mixture of matter and antimatter in it. We're just oblivious to the fact that most of the antimatter particles are things like antineutrinos, and they're not going to interact with anything in the room and blow it up.
Yeah.
The entire universe is a mixture of matter and antimatter. Black holes can eat antimatter, they can eat, and they do eat regular matter, but they are just a blob of high density stuff
Right.
that light can't escape from.
Yeah, and people always say, if you had a black hole's worth of matter and you merge it together with a black hole's worth of antimatter, would they annihilate each other and disappear? And the answer is no. You would just end up with a black hole with twice the mass
And a lot of energy.
that would be
So there's a
gobbled up as
different
well. There'd be no energy. It would just be you would just end up with a
so
black hole.
you'd have a lot of mass energy. Let me
Yeah, you just have a lot more black hole. You have twice the black
yeah.
hole that you had before. And if you had a ball of pure energy that had the mass equivalent of of one solar mass, and you threw that in the pile too, now you'd have three black holes.
The key is that matter and antimatter both have mass. And it's the density of the mass energy. How much mass energy do you confine into a certain volume that defines is something a black hole?
Yep. So we don't know what a black hole is. We don't know what's inside of it, but we know that it's not matter and it's not energy and it's not antimatter. It's
Yeah.
black hole. And anything can go into a black hole and just add to the black hole. So yeah, but so Cujo, I've actually done a whole episode on this on my channel. If you do a search for what if a black hole met an antimatter black hole, and sort of cover that in more detail. And Sergusi's asking, any way to distinguish whether another galaxy is made of antimatter? I also did a video on that called "Are There Antimatter Galaxies?" So check that out. All right, we've reached the end of our hour, so thank you everybody for joining us this week. Pamela, I mentioned this to you before. I like this spot. It looks very cozy.
Okay.
Yeah, this is.
I'll use this spot more then.
I think it's great. Yeah, as opposed to, I mean, having the universe outside your window is pretty cool too. But I think this works out really well. I like the background and stuff. So. Thank you to everyone for watching. Thanks to everyone who asked questions. Thanks to our moderators for keeping things under control. We had a bunch more viewers today, so welcome everybody. And everybody on Twitch, we haven't forgotten about you. What's coming up next for you?
So the next stream that is a certainty is Sunday evening around 10 p.m. Eastern. I will be doing digital space art on my personal Twitch channel, twitch.tv/starstrider. And I am running a massive sale on my artwork, but only for patrons. So if you want to get a massive coupon and decorate your house with planets, look me up on patreon.com/starstrider with a Y. I am transforming all the planets you purchase into gardening supplies. So if you want to see lots and lots of happy, healthy tomatoes at the end of the summer, please purchase a planet.
That's awesome. We've got Dr. Ryan Watkins going to be on my YouTube channel on Monday.
Great.
Fantastic. Yeah, she's with the Planetary Science Institute as well. And she is one of the world's renowned experts on the surface of the moon and the resources that will be there. She's one of the advisors on for Blue Origin for their Blue Moon lunar lander, and is going to be one of the key people in helping figure out how to harvest resources from the moon in the future. So that's going to be on Monday afternoon, normal open space time at 5 p.m. Pacific. So join us then. All right, everybody. Again, thank you so much. We'll see you next week.
Bye bye, everyone.